Okay, gang, good morning. Happy Friday. Today, we're going to continue stuff that we talked about a while ago, factoring out the greatest common factor and factoring trinomials. This is going to be a hard topic that we're starting here today. Speaking of hard topics, I mentioned before we did exponents and radicals that I thought for many students that would be the hardest section of the semester. So we are past that, not to say that stuff is getting easy, but I think that that is some really difficult material with exponents and radicals. So we just handed the quest back. Some people did fine. Some people have some work to do in terms of really understanding all of those rules. And I've said this before, but what makes that particular section tough is that there's so many of those rules. You have to apply them in the right order, and it's really easy to think that you are applying the right rule in the right order, and you're not. And so it just takes a lot of practice. So like I said, we're changing gears here. We're not going to be talking about roots and radicals for a while. That said, on test number 2, which is a ways away, you're going to see roots and radicals again, and on the final exam, you're going to see roots and radicals again. So you have time to shore up that knowledge of roots and radicals between now and test 2. All right, if you have individual questions about your quest, just come find me right after class today or some other day and we can chat, okay? All right, so let's jump in. Again, at the bottom of page 149. So you actually have some stuff already filled in on this page, yes? Yes, yes. So I'm going to remind us of what we did. It was a while ago. But let's just jump in to this problem right here, and then we'll come back and figure out how this stuff relates to what we did a while ago on this page. So what we're going to do is multiply these two things here by using the box method. So this will be a quick review for us. So let's go ahead and fill in. On the left-hand side, I'll put the 3x and the minus 4, and on the top, we'll put the 2x and the plus 5. And then remember, the idea is we fill in every one of these rectangles with the area, what goes in the top left when we multiply the length and the width. 6x squared is good. Go ahead and fill in the other 3 boxes. So multiplying the length and the width. Sometimes you have to look far away to find the length and the width. And if you just put 15x, go ahead and put a plus sign in front of that 15x. We want to make sure that all of our things in the box have either plus signs or minus signs. You could put 1 in front of the 6x squared. That's going to be the first term. It doesn't need 1, but all the other ones will put 1. And so what that means is that if we were to multiply 3x minus 4 times 2x plus 5, we get just all the stuff in the box, right? So I'll read across the first row and then continue across the second row. So multiplying those two binomials together gives us those 4 terms. And we can combine a couple of the terms, so let's do that here. 6x squared plus, what is it? (7x), and then the minus 20, okay? So that's multiplying, that's the easy direction. We're going to talk about going the harder direction, which is called factoring. So here's what's going to happen. I'm going to give you this, that is the final answer we just came up with, and ask you to figure out what 2 binomials that I multiply together to get that thing in yellow. And that's a tricky problem, and that's what we're after for today, okay? So I'm giving you the yellow and asking you to unbox it, go the other direction. Okay, but let's make a couple of observations about this box right here. So first of all, I'm going to write the word sum equals right here. And I'm going to focus my attention on this diagonal right here. What is the sum of those 2 terms in that diagonal? That's 7x, right? Like that's the 7x that's right there in the middle. So go ahead and put 7x right there after the equals. Okay, so the sum of those 2 terms is equal to 7x, fair enough. And what is the product of those 2 terms? So here we're just multiplying. So 15 times negative 8, let's see, I think that's a negative 120. So negative 120, but the x times the x gives me an x squared. Everyone agree? Product is negative 120 x squared. Okay, so let's think about this from the perspective of the information that we're given. We're given this thing in yellow, and we're trying to figure out these two things in the parentheses here. So I'm going to make that 2 by 2 box again. You don't have to write this. We're just kind of feeling our way out here. The only information I have is what's in yellow, 6x squared plus 7x minus 20. Is the 6x squared someplace in this box? It is. It's in the top left. So I can put it right there in the top left, right? Is the 7x in the box? 7x is not in the box, but the 7x turns out to be the sum. And so I'm going to put right down here that the sum is equal to 7x, right? The sum of the two things on that diagonal. I'm going to circle them in orange, but at the moment I don't know what they are. Fair? How about the minus 20? Is that in the box? It is. It's in the bottom right, so let's put it in the bottom right. And I have written down all the information I had that was highlighted in yellow, right? If I give you that thing in yellow, you've written down the 3 pieces of information, and we're stuck. We still need to figure out what goes in the 2 blanks on that diagonal. But there's one more piece of information that we had up here. We had that the product was negative 120x squared, right? That was the 8 times the 15 with x next to each. But I don't know what the product is because I don't know yet that it's supposed to be 15x and negative 8x. But let's multiply the other diagonal just to see what happens. 6x squared times negative 20. What does that equal to? That's negative 120x squared, isn't it? 6x squared times negative 20 is negative 120x squared, which is exactly the same as that 15x times that negative 8x. And it turns out anytime you use the box to multiply a binomial by a binomial, the product on the one diagonal is going to equal the product on the other diagonal, no matter what. And I was teaching this topic for a long time before somebody pointed that out to me. I had no idea that was true. Been doing it for years. I had no idea that the product of the 2 diagonals was always going to be the same. And so what that means is that even though we don't know what the 2 things are in the blanks, I do know what the product of those 2 things is supposed to be because the product on that diagonal is going to be the same as the product on the other diagonal. So even without knowing what goes in the blanks, I can write down over here that the product on the diagonal that I know is negative 120x squared, yeah? 6x squared times negative 20. And so now I can play detective to figure out what goes in those parentheses. What goes in the 2 blanks. What we're looking for is 2 things that add up to 7x and multiply to negative 120x squared. And that is some very specific information, and it's a puzzle that we can solve. It turns out we already know the answer. It's 15x and negative 8x. Those are the things that add up to 7x and multiply to negative 120x squared. The question is, can we do it when we don't know ahead of time? But this is the goal, okay? So let's remind ourselves now what we did last time. So we talked about this guy right here. This is the thing we are trying to factor. We're trying to turn it into multiplication. And so what we did the other day was we factored out the greatest common factor. I think we used this box up here that's highlighted in green. 2x was the thing that was inside of all 3 of those terms, and we figured out what was left over on the top of the box. And so we figured out that this blue highlighted thing is exactly equal to this other blue highlighted thing with the 2x out front. And so now we are going to focus our attention on this thing right in here, okay? And we're going to try to factor that into the 2 parentheses, 2 binomials, using this new technique. So that negative 7x squared plus 4x plus 12 is going to be on the next page. It is right here. So let's see if we can figure out what to do with that thing. All right, we got a blank box up on top. Let's start filling it in. We are given the negative x squared plus 4x plus 12. Where does the negative x squared go? Is that in the box or outside? That's in the box. Which box gets the negative x squared? Top left. Negative x squared right there, yeah? that plus 4x, is that in the box? It's not in the box. But that plus 4x we're going to start putting down here, and we're going to call it sum. The sum of the diagonal is supposed to equal positive 4x. I'll circle this diagonal blank again. And then how about the other thing I know, which is this positive 12? Where does that go? Which spot does it go in? That's the bottom right. So I'll put a plus 12 right there. And so for every one of these problems, and trust me, you're going to do a bunch of them today, that's our format. The x squared term goes in the top left. The x term goes outside the box. We call it the sum. And the constant term with no x in it goes in the bottom right. Every time, that's where the 3 pieces of information go. And we have now used up all 3 pieces of information we were given. We don't have anything else. So the rest of this is on us to create. Next step is to find the product of the diagonal that we have. What do you get when you multiply the 2 things on that diagonal? Negative 12 x squared, yeah? And then that surprising fact is that the product of that one diagonal has to be the same as the product of the other diagonal. So even though I don't know what goes in the blanks on the other diagonal, that thing circled in orange, I know that they multiply to negative 12x squared, and I also know that they add up to 4x. And it turns out that's enough information for us to figure out what goes in the blanks. So you don't need to write this down. This is not the way to go. But I'm going to start listing things that add up to 4x. We're trying to fill in the 2 blanks on that diagonal. I need 2 things that add up to 4x. Would you guys agree? 1x and 3x adds up to 4x. Good. That's one possibility. 2x and 2x, agree? Adds up to 4x. How about 6x and negative 2x? Does that add up to 4x? Yes, it does. How about negative 17x and 21x? Does that add up to 4x? It does. How many pairs of things can I write down that add up to 4x? How many? Infinitely many. Yes? I don't really have time to write down infinitely many things. Focusing on the sum is fruitless because there's infinitely many things that have the right sum. So don't do that. Instead, let's focus on the product. I'm going to start listing things that multiply to negative 12x squared. Here we go. 1x and negative 12x. When you multiply them, agree? It multiplies to negative 12x squared. Good. How about 2x and what's the partner that's going to multiply to negative 12x squared? Negative 6x. Yes? Okay. Next up, 3x. Times what to give me the negative 12x squared? Negative 4x. That's good. 4x goes with negative 3. Is that the same as the one that we just wrote? No, it's different, right? One of them is positive 4x, and the other one is positive 3x. They are different. 3's and 4's are the same, but the signs make them different. Okay, look, I've done 1x, 2x, 3x, 4x. How about 5x? 5x times what to get negative 12x squared? So that one's not going to work, not unless we put a fraction, and we're not going to be putting any fractions. And so you don't do every single one, you just list the ones that work. And so 5x doesn't work. How about 6x? Who's the partner? Negative 2x. 7x? That's not going to work. 7 times something to get negative 12, not unless it's a fraction. 8x? No. 9x? 10x? 11x? 12x? 12x has a partner. What's the partner for 12x? Is negative 1x. And that's it. We have listed every single possible pair of factors that multiplies to negative 12x squared, again, ignoring fractions, and we're never going to put fractions in there. How many pairs did we end up with? 6. One of those pairs is the winner. One of those pairs is about to go in the blank diagonal that's circled in orange. But first, I need you to be with me here and say that focusing on the product is much more fruitful than focusing on the sum. How many pairs could I have written for the sum of 4x? Infinitely many. How many things ended up multiplying to negative 12x squared? 6. 6 pairs of things, okay? So you focus your attention on the product every time, And once you've got your complete list of things that multiply to the right thing, negative 12x squared, you just start adding them. All right, I'll put the sum here in green. If I add up these two things right here, 1x plus negative 12x, I get negative 11x. Agree? No, that's not the one that I wanted. I wanted positive 4x. Okay, how about this one? What do you get when you add these two things? Negative 4x. Is that the winner? No, I wanted positive 4x. The winner is actually really related closely to this one, but let's keep going. When you add up these two, 3x plus negative 4x is? That's a negative 1x, right? Okay, that's not it. How about when we add here? That's 1x. I'll put a positive sign in there. When I add here, that's positive 4x. That's our winner. And when I add here, I'll just keep going. That's positive 11x, right? And so we find all the products. There were only 6 pairs in this case. We add them all up, and you pick the one that works. So the one that works in this case is the 6x and the negative 2x. And so we're going to put those two things into the circled orange space. So let's do that. It makes absolutely no difference which one we put them in, 6x and negative 2x. I'm going to put the 6x right here and the negative 2x right up there. So fill those in the blanks. But again, it's totally okay to put them in the opposite spots. Okay, next up is to figure out what goes outside the parentheses. Don't lose sight of the goal. The goal was to take this thing highlighted in yellow and write it as 2 parentheses multiplied. I'll copy the 2x right down. So all we're trying to do right now is change the thing in yellow to 2 things multiplied in parentheses. And where do those 2 things come from? They come from the outsides of this box. So once we figure out what goes on the far left and right across the top, we throw them into the parentheses and it's done, okay? Understand the big picture process here? Okay, so what we're going to do is look at that top row and figure out what the greatest common factor is in the top row. Look at negative x squared, look at negative 2x. What do they have in common? What is negative x? So you could just say x, that would be okay, but I'd prefer that you say negative x. So first, they both have x in it, yes? And they don't have any number in the front that goes into both. One of them is a negative 2 and the other is a negative 1. So you can't pull the negative 2 out because there's no 2 in front of the x squared. But they both have a negative sign. And my strong preference is that if you are factoring out a greatest common factor and everything is negative, that you pull that negative out as well. Okay, so you pick the greatest common factor out of the top row. We're not going to do this, but look in the bottom row. And yeah, Megan? Yes. Yes. Absolutely. Yeah, so Megan is wondering what happens if we had swapped the green things. So if you imagine that 6x in the top right, and now look at the new first row, they're not both negative anymore. I would just put an x out in the front in that case. Yeah, so where you put things will have an impact on the way the final answer looks, but at the end of the day, we'll get equivalent final answers. Okay, look in the bottom row. What is the greatest common factor of 6x and 12? Is 6, right? But I don't want us to look there. I don't want us to do this greatest common factor anywhere else. I don't want you to put a plus 6 there, although maybe it'll get there another way. Sometimes students will take my idea of, okay, greatest common factor in the first row and do it everywhere, and do the greatest common factor of the second row and the first column and the second column. And oftentimes that works, but it turns out not to work every time. And so we're not going to do that at any point just because sometimes it goes wrong. So first row is the only one that we think about greatest common factor. And now we're just going to figure out what goes out outside the rest of this box by playing detective. Actually don't quite have enough space up there. So can we just copy in this next one that's partially filled in, put the plus 6x there and the minus 2x there. And then outside we decided negative x was the greatest common factor in the first row. Okay, let's look at this box right here. This box right here has an area of negative x squared, and that negative x squared was supposed to be this width times this length, agree? So the question is, what can we put right there so that when you multiply, it by the negative x, you get the negative x squared? What do we put up here? Just what? Just x. So we put just x right up there. See it? X times negative x gives me the right thing, gives me the negative x squared. Okay, let's keep looking. Let's focus on the negative 2x. So the negative 2x is supposed to equal the product of the width times the length. So I need to put something right up here so that when I multiply it by that negative x, I get negative 2x. What's the something? Is it 2 or is it negative 2? It's 2, right? We're going to put a positive 2 right up there with a sign, not just 2, but a positive 2. And then we'll check. Positive 2 times negative x. Yep, that gives us the thing we want, negative 2x. Now focus on the 6x, bottom left. The 6x is supposed to be the product of a width and a length. The width is this thing right over here. The length we have already filled in. What's the length of that box in the bottom left? It's x. It's this x way up here, right? So it's these two guys multiplied together is supposed to give me this plus 6x. What goes in the circle? 6, positive 6. So we put it right there. Okay, so to summarize, we look in the first row only and pull out the greatest common factor. But once we've got that thing written in the front, on the far left, then we just play detective and we start making sure that the areas all work. We know the areas inside of all these little boxes and we just put things outside that make the correct areas. There is one thing of these 4 boxes that we have not even paid attention to in the purple. What didn't we even look at in the box? We didn't look at the 12, right? We looked at the negative x squared, then we looked at the negative 2x, then we looked at the 6x. We did not look at that 12. Well, we better hope that it works because we have no more freedom, no more choices to make on the outside. So does the 12 work? Well, the 12 is supposed to be the product of these two things, right? That width times that length. Does it work? It does. If we do everything right, it's going to work every time. If you make a mistake, this is a good opportunity to see, oh, I've made a mistake. If somehow up here, we hadn't put a +2, but somehow we came up with a +3, what should be in the bottom right now? 18. And as soon as I see that it's not 18, I say, okay, something either outside the box or inside the box is wrong because I cannot have a 6 and a 3 there with a 12 inside. So it doesn't really help you identify like what the mistake is, but it lets you know there's a mistake, or it lets you know, hey, you probably did everything perfect if it works out. Okay, so I think we're ready to write down our answer now. Looking at the stuff on the outside of this box, negative x plus 6 right there, and then x plus 2 right there. And that's the process. Okay, let's move on to the next page. Before we send you to the activities, I'm going to show you in number 22 a table that might help you kind of organize your thoughts. Like I said, this is a very complicated process. It's a long process. As with a lot of things in life, it gets easier with practice, but maybe this template that I made here will help. So can somebody remind me, what was the thing we started with here? It was a negative x squared. What was it after that? +4. +12 at the end. Is that right? Okay. So in the activity, you're going to see a lot of copies of this table right here. It's the same box as we had before, but it's got some numbers, little numbers that are supposed to help us know what to do with each of the pieces. So take a look. I'm calling this negative x squared the first term, 4x is the second term, and +12 is the third term, okay? Just always in that standard order, 1, 2, and 3. And so we start filling things in the box in that order. The very first thing to fill in is the one with the little 1 in it. So what am I putting in this box with a 1? That's the negative x squared, put that there. The next thing is the one with the 2 on it that says sum. It's not in the box, but outside. What am I putting in the sum line? 4x, we'll put a positive 4x there. And then back in the box, I see 3. What goes in the 3? Positive 12, okay? So we put 1, 2, 3, like I said, always in that order. And where do we go next? Well, we just did the third thing, so we must go to the fourth thing. The fourth thing is the product. So we multiply the two diagonal things that we have together, and what do we get for the product here? Negative 12x squared. This is all exactly the same as we did before. I'm just kind of bringing it all together here and making sure we see the order. It's this consistent order every time. Okay, what do you notice about 5? Anything special about the number 5 in the box? There's 2 of them, which means you are filling both of those things in simultaneously. This is the hardest part. Everything, the first 4, it's all easy. It's just this mechanical, you copy 3 of them down and you multiply, and that's the 4th one. That's really easy. Those 2 5s is the hardest part of this process. And this is where we played detective and we said, can we find 2 things that multiplied to negative 12x squared and added to positive 4x? We're not going to list it all again because we've done it before, but the 2 things that we found were positive 6x and negative 2x. You can put them in either spot. I think we ended up putting the negative 2x up here and the positive 6x there. Okay, but those 2 numbers go in at exactly the same time. And those were the 5s, and so now we go to 6, and you can find the 6 is in that top row because we're always just going to the top row and pulling out the greatest common factor. What did we decide for the greatest common factor in that first row? That was the negative x. I'll pause here and say there's nothing special about the top row being the one that we do the greatest common factor for. You could automatically just do the first column every time, or the second row, or the second column, or you could do it first column on this problem, second row on the next problem. It makes no difference. You can pick any row or column to start with, but you only get to do that greatest common factor once. I just always start with the top row. That's just what I do. And then 7, we figured out that that was an x by looking at this thing here in the 1. And then we went over to 8, and we said negative x times something. I think the something was a positive 2. And then we came over here to 9, and we said, oh, x times this thing better be plus 6x. So that was a positive 6. And then you can verify the 12, and it works. Okay, so that's the template. Hopefully not intimidating with all the numbers. The numbers are just supposed to tell you the order in which you fill things in, okay? It took me a surprisingly long amount of time to make that thing in Microsoft Word, but hopefully it helps. Okay, let's move on to the next page. So the activity on the next page, there are some problems in number 1, which have to do with the greatest common factor. Let's pause on those and jump right to number 2, because number 2 is the stuff that we just did here. So we'll do a bunch of number 2. At some point, I'll tell you all to go back to do number 1. So start with number 2.